So in the last two videos, we spoke about step 1 and step 2. Step 1, which is project creation, and step 2, which is data. Now let's jump to step 3, which is modeling. In order to move into modeling, we must know actually the different types of machine learning. So we should know which one we're going to use. Are we going to use supervised learning? Are we going to use unsupervised learning, transfer learning, or reinforced? This is very important. And we all know that in supervised learning, that means it works under supervision. We have labeled data. So what we do is we provide the machine with input and corresponding output, so the machine learns from it. And now, after completion of training, we give it the test data set and it works. So the machine tries and fails until when it succeeds. In supervised machine learning, there are two main categories. We have classification and regression. And classification is more about classifying items. So we have binary classification. Binary classification is classifying maybe two items, or we have maybe two options. That is, is he a cat or human? Is this a pear or an apple? Is this white or yellow? Things like that. And we also have multi-class classification, where the model has to actually classify many different items. So in regression, it's mainly about estimating numbers. For example, we can be estimating the number of customers that are going to be purchasing a certain product based on the previous purchases. So that is it about supervised learning. In unsupervised learning, it means it doesn't work on supervision. So in unsupervised learning, there are no labeled data sets. The machine is the one to find patterns with the data it is given. So in unsupervised learning, there are no training data sets. In unsupervised learning, there are two categories. We have clustering, we have association. Clustering is trying to group data according to their similarities. For example, we can give the model a different type of fruits, and the machine is going to group the various different types of fruits according to their similarities. And in association, it's all about trying to find the relationship between certain items. In transfer learning, it's about using what the model has learned in another machine learning algorithm. So that is what we call transfer learning. So you can actually be facing a problem and you're like, oh, I've seen this problem before. Then now you use the model you used before in another model. That is it. And in reinforcement learning, it learns from try and error, it learns from feedback. So when it does something positive, it's being rewarded positively, and when it does something negatively, it is being rewarded negatively. A good example is going to be that of a video game. When there's a score, we give it a +1, and when it loses, we have a X. So that is it. When we know these different types, we actually know which one we are going to choose. The most common ones are going to have is supervised, unsupervised, and transfer learning. When we know these, under these various types, there are any models trained for these, there are algorithms under them, and we are going to choose the one we're going to work with. So what we're going to do is we're going to split our data into 3 different sets. We have the training data set, the validation data set, and the test data set. Most of the time, people use just 2 sets, that is the training set and the test data set. Anyone you use that's suitable for you. It's very important to divide this. Why? Let's take, for instance, you're in school and you're preparing for a general exam. They're going to give you courses, that is the training data set, and now you're going to learn from it. Then your teacher or instructor is going to give you a validation test. And when you validate the test, now go now to the final test. So that is how it functions. If your validation exam was equal to a final exam, you're going to score obviously an A+. Maybe not because you actually understood it, but just because you crammed what happened in the validation exams. So that is what we don't want with our model. We don't want our model to be too perfect. We actually want our model to learn and be able to perform well with unseen data. That's what we call overfitting. Overfitting is when the model performs too well. Maybe the test data set has leaked into the training data set, so the machine performs too well. And now when it comes into another data, accuracy is really, really low. And we also don't want to come across the problem of underfitting. Underfitting is when the machine performs poorly. In most cases, maybe it's because we don't have enough data to train a machine, or because the data we use to train a machine is clearly irrelevant to the data we test, and we don't want any of those situations. We actually want a machine to be generalized. That means we train it, it learns, then it's able to perform well on unseen data. That's actually what we are looking for. And when we're done with this, All we have to do is tune our model. Tuning is very important because it helps you improve the quality of your model. For example, you might be cooking your cake and maybe the cake comes out a little bit too hard. So you might take another test with maybe trying to exchange the ingredients you use and see how it can come out spongy or delicious. So that is tuning. In the next video, we're going to be seeing the last step, that is deployment. So see you in the next video. Thank you.